right, we're going to go into our next section of our discrete random variables. Okay, and so the two things that we want to talk about today is if you have more than one of these unknown events, okay, how are you going to combine them together? There are some certain rules, and so we want to talk about those. We want to hopefully do it in an intuitive way so that it makes sense, so that it's easy to remember the effects that are happening when you are combining those variables together. Also, we're going to be doing remembering the transforming and the effects of the transforming. And we've done that already before, so that part will be just a small little review. Okay, so here we go. We'll start with the transforming. And so, what we want to discuss is, what happens when you add or subtract or multiply or divide? What is happening to those values when you are changing them, such as that? So, we've already talked about that. How is that affecting the center and the spread? How is it affecting that mean? And how is it affecting that standard deviation? So, here we go. Here's a kind of a visual. Besides, if the visual you remember, the ball that I would expand and compress and shift left and right to talk about how those changed. But let's recall that the shape of our distribution will not change if you add, subtract, multiply, or divide. It stayed a ball the whole time. Whether we shifted it by adding and subtracting, it stayed a ball. Whether we multiplied it or divided it, stretched it or compressed it, it still stayed the same shape. So the distribution stays the same. The center is affected by add, subtract, multiply, and divide. The center of the average of all the data, add, subtract, multiply, divide, will change where the center is located. But remember that spread is not affected by the adding and subtracting, only affected by multiplying and dividing. Okay, so here's another kind of visual for you to look at to remember those. So let's take this and apply it to context. And so we've got this problem here where we've got Joe's Pizza and Pasta. And, if you have this business, then you want to be able to make these types of predictions. You have to budget properly. So, what this company is doing is they've had their commercial grade washer for the restaurant for 4 years. And so then they know the expected number, or they've researched it, and they know this expected number, or the average number of repairs that this dishwasher have is 0.45 each year. On average, see, in the long run, that's the amount of repairs per year on average. Anyway, and that standard deviation is 0.6, okay? Now, they want to turn those repairs, they want to transform them into a cost function. So they know that they could purchase a service contract where they pay a flat fee and then just a $65 service charge for each repair. So that is a lot cheaper than maybe the alternative option that they have. So here is the cost for that, and that is $110 plus $65 service charge per repair. So find the mean cost and the standard deviation cost, transforming from number of repairs to cost. Okay, so take a look at that, see what you think that would be. All right, let's check and see how you did. Of course, our function for the cost, okay, so our function for that cost is that $110 plus 65 per repair. Okay, so there's that function that we have. And so then we put our data through that function, and it looks like this. So that mean 110 plus 65 times 0.45. So there we have on average, they should budget this much for their cost for the dishwasher yearly. And then with this standard deviation, no plus 110. The spread was not affected by that flat fee of $110. So just the multiplication. All right, so that standard deviation is $39. There's how much variability there is in the cost for each year. All right. Now we're going to go into combining variables together. So you have a company, you've got multiple components, a dishwasher, ovens, different appliances. You are needing to do this in terms of those items. Okay. So you can build your budget for your company. A business plan is what you are trying to get. So guess what? Our means do just as we would expect them to. We're going to find that all year long, that our means, the expected values, add, subtract, multiply, and divide, combine, add, subtract, all those kinds of things, just like we would intuitively expect them to. But we will also find that standard deviations have special rules all the way through. Okay? Standard deviations. That standard deviation, has always got something special going on. So, anytime you are asked to do something with standard deviation, you need to stop and think because that diva's got something going on. Here we go. So, we find that we cannot just add and subtract those standard deviations together. So this has to do with some different. I've looked up why is this, and it really is math past what I want to get into. Has to do with some orthogonal vectors and two-dimensional things, and some actually, getting some bigger math components involved. I just didn't really want to get into it. So in general, we're just going to kind of remember that our standard deviations, when they combine, they have to be those variances to be able to combine. So they have to be those squared values. So we kind of have this thing going on, this Pythagorean theorem of statistics, where we have this a squared plus b squared equals c squared. Okay, so that's what's happening with those vectors and those distances. It's not as the variability isn't as simple as just adding the variability of one and the variability of the other. Okay, it's not quite that much. So we have this here, Pythagorean theorem. So the c would be the square root of that a squared plus that b squared. All right, so let's apply this. Here we go. So we're going to see, and sorry, one other little thing that I'll come into, and I'll kind of give you a way to remember this as well. Here's the other little special rule that what happens is whether you are combining standard deviations or subtracting them, whether you're finding the a total of two variables or the difference between two variables, the standard deviation of them combining or subtracting still gets bigger. So it adds whether you're adding or subtracting. And I'm going to tell you a little story about cereal and a bowl, and then that'll hopefully help you remember why this is the case. All right, so here we go. Let's put this into action. So here we go. We've got our business again, and we've already figured out that our average cost we're allotting for our dishwasher appliance was that 139.25 with a standard deviation of 39. Okay. Our other appliance that we're going to be dealing with is our oven, our big commercial oven that we're doing with our business, and it's got an average of 115 plus a standard deviation of 27. Okay. All right, so there is the mean and standard deviation for those. So what would be the expected values? What should you, as a business owner, budget? What do you expect on average for this cost to be total between those two repair contracts? And so that is just adding those two averages costs together. Okay, so there we have that average of the dishwasher plus the oven. But let's do the standard deviation. Remember, the standard deviation is got the special rule. It's going to be through the Pythagorean theorem of statistics. So we're going to have that square root of the dishwasher standard deviation squared plus the oven standard deviation squared. And so that comes out to 47.43. See, the variability is not quite as much as just adding 39 and 27. That's a lot more variability than what really actually happens. So on average, as a business owner, my business plan should budget about $254, 255, whatever, but with this much variability. So 68% of the time, I anticipate being within one standard deviation of that average. Okay, and so that's going to give me an indication of how much I can be on and off. Okay, think of this on a much bigger scale. That's what companies are doing every year, all the time, to get those budget meetings and take care of those things. All right, so let's discuss that subtraction component. So let's say that we've got this Lucky Charms. Well, I've got honey roasted or honey bunches of oats. Honey bunches of oats. Okay, so whatever it is that you've got there, I actually really like uh, Fruity Pebbles. Those are my favorite. Okay, so here we go. But here we have an average box of Lucky Charms that contain 12.4 ounces. This one has 23, but 12.4 ounces of cereal, okay? And do you know what? Do you think that this box of cereal, when it's going down the assembly line, it's actually going to get always exactly 12.4 ounces in it? Or is there going to be some variability in what the machine puts into this cereal box? Of course, there's variability. So we have that standard deviation of 0.1 ounces. Not always going to be 12.4. Okay, now, so there's that. We also have this situation. In a typical morning, you get up and you pour yourself a bowl of cereal. And so you're going to pour yourself a bowl of cereal. Well, it generally holds about 1.6 ounces on average. Okay, but you know what? A person, of course, is not as exact as the machine. So there's a little bit bigger variation there. 0.2 ounces for our bowl of what's in here. Okay, so here we go. Now let's talk about what gets left in the cereal box. Find the mean and standard deviation for the amount that is left in the box after you have poured yourself a bowl of cereal. All right, here we go. I start with my 12.4 ounces. I'm going to pour out about 1.6. What's left in my cereal box on average? Okay, well, it is intuitive. It is what you expect. It is your 12.4 minus your 1.6. Okay, done. There's about 10.8 ounces left in my cereal box. But here's where it gets special rule. That's special standard deviation. Here we go. So I think about this variability. I wasn't sure exactly what we started with in our cereal box. I'm not sure how much I poured into my bowl. So tell me about my certainty of what remains. Is my variability smaller because I'm subtracting? Or I wasn't sure what was in here. I wasn't sure how much I poured out, so I'm even more unsure of what is left in here. My uncertainty increased, even though I subtracted out my amounts. So, my subtracting the box minus the bowl. Is that standard deviation squared plus the bowl standard deviation squared, and then square root that. So see, look, my uncertainty increased even though I was subtracting box minus the bowl. So there is my way to help you remember and understand why that variability gets larger, even if you're subtracting. All right. So that was the main idea there. Okay, so that is the lesson part. Now we just go through and we do some application and some practice. So what I want you to do is read this. I'm going to go ahead and stop this video here. Okay, and so then I want you to take a few moments and go through these problems. See what you can come up with. Think through this and process it in your own time. And then watch the next video and we'll go over this application and see how you did in getting those topics of the transformation and the combining rules. All right, good luck to you.